Thanks everyone for coming to the Tech Talk today. Really happy to have Michael Coates here, who's the Director of Product Security at Shape Security. He's also the Chairman of OWASP, and he's going to talk to us about the top web vulnerabilities. So let's give Michael a warm welcome.
Great. Thanks for having me back. I didn't get escorted off the premises between the last talk and now, so must not have messed up too bad. That's good. How many people here were here for the first talk? Awesome. How many people are new? Does everybody know what closes on Friday? I've heard it 4 times. Okay, cool. So this talk is going to be different, which is good. We're not going to do the same talk again. This one is more, I'll say hands-on. What we're going to talk about is top web vulnerabilities, how you exploit them. How many people have actually hacked into something before? A few of you. Perfect. So you're going to learn how to hack into a vulnerable web app using common exploitation for things like SQL injection, cross-site scripting, and access control failures. Now, I'm going to show you the virtual lab. I have it running here, but I'm also going to give you instructions on how to download it, how to set it up yourself, and you'll have all the tools at your disposal to use what you learned today and actually compromise a real application. The idea being, after you do it yourself to compromise a system and exploit a vulnerability, you'll see how easy it is for an attacker to do that type of activity, and hopefully that will translate into some additional thoughts when you're building your applications, and that moment clicks, and you're like, wait, what if somebody does this thing I just did the other day? They could abuse this, this could happen, this could be really bad. So you know about me. Oh, that's a little blurry. Very brief, because most people were here. I'm at Shape Security. I used to be at Mozilla, ran the security program there for Firefox, websites, servers, etc. And when I'm not working a day job, my night job is as global chair for the OWASP board. OWASP is a great organization, lots of free security resources, lots of goodness there. Please check it out at owasp.org. So very quick, setting the stage, the reality of security. These headlines are pretty easy to come by. I've used these for a few months perhaps, but I can refresh them just by doing a Google News search, as we talked about earlier. The number of compromises are astounding. They happen every week. Just a few weeks ago was Target. Before that was Adobe. Big names like LinkedIn compromised a few years ago. A rash of startups always compromised. And we've got criminals coming after us. That's just the reality. So we have to level set on that. Let's be aware that the vulnerabilities are not, a bunch of kids at universities just trying to exploit them. They are real criminals coming after us. A few interesting stats. In 2011, this quote came out that the global cost of cybercrime was greater than the effect on the economy of marijuana, heroin, and cocaine. Interesting. And in 2013, a study by Norton, I believe, revealed that the global price tag of consumer cybercrime was over $100 billion. For context, drug trafficking as a whole is tough to measure, but numbers come in around 300 to 400 billion. So what we're talking about is a third of drug trafficking worldwide. So not small potatoes. Regarding data loss and breaches, 2 interesting sites to look at if you haven't before. The Verizon Data Breach Report, chock full of interesting data on breaches that they investigate. They showed that 52% of the breaches they investigated stemmed from hacking. DataLossDB.org shows in 2013 hacking accounted for 48% of the data loss incidents that they processed. For those attacks, the vast majority of them come from outside the organization. Verizon shows that at 92% and DataLossDB at 64%. The reason this is important is if you think you don't want to be lulled into the false sense of security saying we screen our employees, it's always an internal attacker, they need elevated access to do these things. That's not true. These attackers come from the outside, just like anyone on the web. On the web, you always live on the most dangerous street. The criminals are always next door, no matter where they live. They can just walk to your website and attack you. So the strength of our website, the security of our website, facing the rest of the world is critical. So what are we going to talk about? We're going to talk about three big application security risks, cross-site scripting, SQL injection, and access control. If you haven't heard of the OWASP Top 10, that will list the, well, you can guess, the top 10 security risks facing applications. These are a few of them, but if you haven't heard of it, I strongly encourage you to check that out. You want to be very familiar with each of those and be very confident that you don't have those in your application. As time permits, we have 3 other really interesting topics. Who's monitoring your traffic? So we're going to talk about some common pitfalls in SSL. Briefly talk about how to correctly store passwords and store sensitive data. And then lastly, just a little extra nugget of goodness, some growing threats that are coming. They're not as well talked about. You may not have heard of them, and so we'll try and touch on those. This warning is very important. A few years ago, there was an individual in England who made a donation to, I think it was a hurricane relief fund, and he thought he was being scammed after he submitted the donation. And so he said, well, what website is this? Let's jump back up the path a little. Let's type .. and step back on the URL. That action that he took of .. was recorded in that website's IDS as an attack, as a directory traversal attack. They found his IP address. They found from his ISP who he was, and he was charged with a crime. In the end, I think he might have been found innocent, but he was a security professional. He was fired from his job, and he had to go through all the fun of court. The reason I tell you all this is don't attack other systems. The legal system trails behind understanding technology, and you don't want to be in that position of arguing what is probably true, that you weren't doing anything wrong, but it's no fun to argue that. But what we will do is give you something you can definitely attack, and this is a virtual security training lab. I'm going to jump through these slides actually very quickly, but what I did put here at the bottom is there's a link to how to set up this virtual lab. And if you don't want to remember that link, I just tweeted it from my Twitter account, which is also there. So that might be easier to remember. So very quickly, what you're going to set up, and I have running here and will demonstrate, is a virtual lab running something from OWASP called WebGoat. It's a purposely vulnerable software. We're going to use a proxy tool. How many people have used a proxy tool? A few. Yeah, more. We'll talk in a moment about what a proxy tool is. OWASP also makes a proxy tool called Z-Attack Proxy. It's made by a guy in England, so that's why I use Z instead of Z. Your browser, and then a virtual machine. The virtual machine would be VirtualBox. So everything here is totally free. These slides, again, are online, and we'll jump through this. Real quick, a proxy is a software that runs on your machine, and it sits between the communication from your web browser and the application that you're going to. The reason that we do this is because it allows us to intercept the traffic after we've sent it from the browser. We can then pause that traffic midstream and say, what should we change? The web application displayed all these great things. It had a drop-down box with options 1, 2, 3, 4, and I selected 3. But I'd like to pause that traffic and look at the raw HTTP request. And that's where you see, get, the URL, the actual parameters, the URL arguments. I'm going to now change that 3 that I selected to be the letters ABC. It was never possible before because the drop-down box just said 1, 2, or 3. But when you intercept that traffic with the web proxy and work with the raw request, you can do whatever you want. And so a proxy is not a malicious tool in itself. It's a hammer. You can build a house with it, or you can hit people in the face with it. For this example, we will choose to hit the web application in the face, so to speak. There's some steps on how to turn on the proxy. You'll configure that in your browser using the proxy itself. And that's a small screenshot, but what you can see is that when you intercept traffic, you'll see the raw request going across. So the GET, the URL, all the headers. If there's post data, that would be in there as well. So to demonstrate the idea of a proxy, there's an example in the lab where you would submit from your browser username Joe. You'd intercept with the proxy and change that to Sue. The web server would get the name Sue, and the application on that, the web server, the page we're using, is instructed to reverse whatever you send it, and so it would send back the reverse of Sue. So just illustrating that the proxy stops the traffic, it allows you to make any sort of manipulations that you want. So jumping into these vulnerabilities. So before we get into the first one, this fundamental point is pretty important. If you were to open up a console and enter telnet Google space 80 and then that get, what would happen? Anybody? I hear whispers. I think somebody knows. So fundamentally what you'd be doing is simulating a web request. You'd send a totally valid web request, in fact, to Google. You're saying, give me the root page, give me /. Now, the reason I mention this is because the browser is not our limitation. And when you're thinking about it, defending your application, you shouldn't think that whatever the browser gives the user or whatever is displayed to the user in the browser is the limitation of what they can do. Just like I could type a lot of characters in a browser, I can type even more in a console window. I could send you 5,000 A's because I felt like it because I typed them into a console. So one of the fundamental things that leads to vulnerabilities in applications is a misunderstanding of what the attacker is capable of. So remember that something like JavaScript-style defenses are all client-side. They make things pretty, but an attacker can always step around anything client-side and just send, again, whatever traffic they want to send. So, cross-site scripting. The name is a little misleading. It's more like JavaScript or HTML injection. I think that is actually a more accurate term. The idea of cross-site scripting, you see a page here, is this is the classic alert box that pops up. If people have ever demonstrated cross-site scripting to you, you may see this message box pop up on the screen. And what they're demonstrating is that they were able to inject JavaScript into the page. The JavaScript that they chose to inject makes an alert pop-up box to be very visible. And in that pop-up box is this data, which is actually a session cookie. The reason they show you the session cookie is there's two things I could do to take over your account. One, I could steal or guess your password. But two, I could just steal your session ID. Because after you log into an application, every time you go to a new page, you don't log in again. And that's because there's a long numeric value, the session ID, which I imagine most of you are familiar with, that represents you for the server. And if I take that value, then I become you. I don't need your password. I have your session ID. That's all that matters. So if I was able to inject JavaScript into a website that executed and accessed the session ID, I would just ship that value off to me as an attacker and then log in as you and do lots of bad things. So the problem with cross-site scripting is when user-controlled data is sent back in an HTTP response, and that contains HTML or JavaScript code which is not properly encoded. And by that I mean it is executing the page versus being literally displayed verbatim. With cross-site scripting, what I can do, I'd steal your session. I could fully control the page. As you know, using JavaScript, you can rewrite every element of the page. You can change anything you want. I could just send you off to a malicious site that does like a black hole exploit kit, if you're familiar with that. A common exploit kit that will exploit a vulnerable plugin or browser to install malware on your machine. So let's dive into what's going on with cross-site scripting, and then we'll do an example in that virtual lab I talked about. So let's say we created a page called Shiny Page, where we pass the username in via a URL argument. So username equals Bob. A very basic example in JSP might be this: glad to see you, get parameter, name. This would actually not work because it's user, but let's ignore that. HTML source would then say glad to see you in bold, Bob. And this is what you would see here. It's actually a multi-step exercise. If you've noticed the code flaws, we don't actually have the bold tags up there either. But nonetheless. So in the normal situation, you would do this, and you would see this. This is the correct way we've designed the application. Everything is working great. But what happens if I, as an attacker, enter this? Instead of username equals Bob, I say user equals friend, and then put all this extra HTML. Might be a little tough to read the red on black. What that is valid HTML that will turn into this. So now what I've suddenly done is taken a page that you hope to just display a nice greeting for a user, and I've made a login form that will, when submitted, post the information off to me as an attacker. So that's an example of cross-site scripting where you choose to inject HTML instead of JavaScript. Okay, and we talked about this. Here are a couple examples of generating the pop-up with the cookie. You could do a redirect to a bad site, rewrite the page on the fly as we talked about. If you wanted to do some very basic tests against your application to say, is this page blindingly vulnerable, just obviously vulnerable to cross-site scripting, you could type in this here. Some people have asked before, why do you add the double quote and the greater than? If this is going into an HTML attribute, this will escape out of that. It'll close that attribute, then close the element, and then start a new script element. Now, an attacker has no motivation to show a pop-up on your screen. So what a real attacker might do is something like this, where they redirect you to another page and attach the cookie to it. So then on the attacker site, they have a script running that parses that cookie out, automatically logs in as you, purchases some pictures of cats, logs you out, something like that. Now, I promised that we would look at the actual lab, so let's do that. So once you have it set up and running, you'll have VirtualBox running like this. You'll have the VM boot up. You don't actually need to do much of anything in the VM itself. It just displays an IP address. Oh, you don't see anything, do you? Trick. There we go. So you'll have VirtualBox running. You'll get an IP address there, and that is where you log in with your browser on your main machine. One 192.168. Okay. So when you do that, you'll see that this is a VM image, a virtual machine. There we go. And there's a lot of different applications on here to learn about security. The first one being actually. For those that were at the last talk, the AppSensor, there's actually a social networking AppSensor demo down here, kind of illustrating some of the ideas we talked about. But this is what we'd use here, WebGoat. Password is guest. Sure. There we go. Running a little slower than normal. It actually runs quite fast normally. So our first example is under cross-site scripting, and it is the reflected cross-site scripting attack. So what we saw before was that we could inject, essentially, let me pull up a notepad so you can see it. That this was the type of basic attack we would inject. Because this, in many situations, if the page is very vulnerable, will fire. So one way is to go through and inject one at a time and see what works. Another way is to just hit them all at once and see if any of them are vulnerable. And there we go. So what happened here was there was an error message right here. It says, whoops, you entered 111 greater than, double quote greater than, instead of your 3-digit code. So we can assume that the error was down here. And what happened was the error message returned to the page verbatim what we entered, without consideration of, could this be interpreted by the browser as code? And so we see right here, it says, whoops, you entered 111. In the normal case, that's a good error message telling you you entered something incorrect. But the developer did not anticipate that error, that what they entered could actually include the script. And we see it here as part of the page, just like as if the developer added it originally. So that in itself is a classic example of cross-site scripting. This is called reflected cross-site scripting, because when I enter it in the page, it fires immediately. Now, if I wanted to weaponize that, I would need to do one of two things. I would need to send that page to a victim and say, please type in this script into that 3-digit code, which probably wouldn't work. It's kind of like saying, please, shoot yourself in the foot. But what you can do in many situations is figure out what variable name is that. If I make that as a GET request with that URL variable included, will the attack still work? And in many applications, the request GET parameter will check from a post field or from the URL. And so in this situation, I could actually convert that attack to a malicious link, send it to a friend and say, hey, you can get 20 extra rubies if you log into your page through this link. They'll go ahead and log in. It'll fire off this attack. It'll send that session ID off to me, because remember, the pop-up box is only proof of concept. The attacker uses the redirect. And suddenly, I have his login information, or at least the session ID, and my friend is angry that he didn't get free gems. Now, the difference between this and something else called stored, and we won't do this lab, but you can do it, is that a stored attack is, I take that JavaScript and I put it into the server and it stays persistent. So an example here is like a message board. Say I created a message that was stored in the system, and anytime anyone clicked on that message, the JavaScript that I entered then fired. So I don't need to send you a malicious link and convince you to click on it. Instead, I just put my attack in the site, leave it there, and anyone that stumbles upon it will then become a victim. So how do you protect against cross-site scripting? The problem, as we said, was that the browser gets confused between the characters being sent down. Should I execute these characters as part of the page, or do you want me to render them and display them literally? And so what we do is do encoding, output encoding, where we convert those characters that are confusing into HTML entities, where the browser says, okay, you want me to literally display the less than character or the greater than character. And that way the browser knows how to handle those characters safely. Now, one thing to keep in mind is this is specific for the context that the data is being output to. This is how you do it for HTML. But if you're putting the code into JavaScript or CSS, you want to make sure you're encoding the correct characters for those as well. Now, if we were doing output encoding and we went back to this malicious page with Bob, if someone could still type in this information, because we're not preventing what the user can type in, but what would happen is we would properly render that, or properly handle it, so when the page is rendered, that text is displayed verbatim. Now, the user would be safe in the sense that they don't see the login page. They're not going to accidentally give away their credentials. But they would see this messy input that doesn't make any sense. But what we've done is shift it from a security issue to a usability issue. Now, this is where you might want to have some limitations to make it a better user experience. Say, oh, that's not correct input, something different. Now, for cross-site scripting, you can, again, dive in deeper. There's a few resources here. There's the prevention cheat sheet from OWASP, something called content security policy, which if you're building a new application from scratch, I highly recommend you dive into that. It's a way of completely wiping out cross-site scripting by using browser-based controls. I won't go into all the details, but it's very interesting. And then there's another OWASP XSS overview video to look at. Jumping to the next one, SQL injection. So the kind of screenshot I have here is of a database dump. A lot of times with SQL injection, what ends up happening is you will get access to the database. The ability, you essentially have the ability of someone sitting in front of the database running arbitrary commands. You can read records, you can update, you can drop tables, you can do kind of whatever you want. And so the problem with SQL injection is pretty similar to that of cross-site scripting in the sense that data is being sent by the user, and then a system that's receiving it gets confused on how to handle it. You sent me this single tick character. Is that something you're literally searching for in the string in the database, or is that a command character that should be interpreted as part of a database command? So we'll jump in quickly and show an example of SQL injection. So what we're going to do in this lab is the page says it's a lookup query, and it says enter your last name. Now since this is a training lab, what they've done is displayed here at the bottom what actual query is being run, which says select star from user data where last name equals your name. So if we typed in a name like Bob, it may return information associated with Bob. But what we're going to do is type in some extra characters like the single tick, and you can see I've done this before. And why don't we just use this one? So we're going to say Bob single tick space or single tick 1 single tick equals single tick 1. Now if we run that, we'll let the Jeopardy music go. I do swear, actually, it's much, much faster normally. But rebooting it now, who knows how long that would take. So what happens here is this is the SQL statement that was run on the underlying server. So instead of looking where last name equals Bob, I actually completed the SQL statement correctly here, and then I added on or 1 equals 1. So what we suddenly did was changed it from look up all records of last name Bob to select star where some condition we don't care about or true. And so now in this situation, it's selecting every record from the user data table. And so we have all sorts of information about lots of people, not just Bob. Now, this example is actually something you can do on login pages of websites, because years ago, when they were starting with, let's see, ASP, someone asked, how do I do a database-backed login? So someone gave them a snippet of code very similar to this. Put select star from username password where username equals X and password equals Y. And that was a real snippet of code on the web, and a lot of people copied it. And so what you could literally do is use or 1 equals 1 to log into web pages as arbitrary accounts. And that worked for many years until they got burned by that and finally fixed the issue. So this is not just a made-up example by any means. Now you can imagine that based on the underlying SQL that is being executed, that those statements could get a little bit more complex. But fundamentally what you're doing is just making that the SQL that you add not break the command. But the flaw is still the same. So this is that same flaw, and this is the username and password flaw spelled out a little bit more clearly. So imagine an example where you post an ID number and a password, and this is what I choose to add as my password. The vulnerable SQL statement is built like this, and what the resulting statement is this, where name equals 112 and pass equals X or 1 equals 1. And since we know or 1 equals 1 is always true, that will return a true and let you into the application. So you can actually do the username and password bypass via SQL injection as one of the virtual labs. So the solution for SQL injection, just like we talked about output encoding for cross-site scripting, is to make it so the receiving system understands what you're doing. Am I sending a single tick that you should make a control character or a literal single tick? And that's through parameterized queries. That eliminates that confusion. So in that previous example, we could still type the password of single tick or 1 equals 1, and the database would literally look for someone with that password. And if you didn't have that password, then it would correctly not log you in. Input validation, a lot of people talk about as a defense to protect against cross-site scripting or SQL injection. It is and it isn't. It's a good secondary item to do for kind of good hygiene. You shouldn't let random characters in that you don't need. But you can never really use input validation completely to protect against these issues. Because how would you handle someone with a username of O'Malley? Like Irish people just couldn't use your application because there's single ticks legitimately in their name. So there's lots of situations where that doesn't work all the way. On the same note, do you need non-printable characters to be submitted to your database and clutter that up? Probably not. So you can use input validation as good hygiene. OWASP also puts out a SQL Injection Prevention cheat sheet. The idea of these cheat sheets is to provide the core information you need in about 1 or 2 pages. You could always go and buy a big, huge book. What I found with big, huge books on security is they sit on desks and they're big and huge. People don't tend to read them that often. So we tried to make cheat sheets that were to the point, give you the core information that you need. All right, so the third item I wanted to talk about in terms of vulnerabilities was access control. The biggest problem that we see with access control is that you have a system of controlling, what kind of access can you have? Should you be able to see this, execute that, operate on this data? And a flaw comes into the play that you either didn't anticipate or you missed an edge case of your situation, of your design. One very classic example is just, again, not realizing that users can change pieces of data that could give them access to other information. So this example here says, somebadbank.com show account ID equals 101. If I ran that, I would see, and if I owned account 101, I would see whatever information is there, my balance, my transactions. As an attacker, what I would then do is say, well, what about 102? And if I typed in 102, and that somebadbank was a major bank in the US, perhaps one of the top 10, and it was about 2 years ago, that would actually show me someone else's bank account information. Because just like the username and password example, this is not made up. This was a real issue from a major bank about 2 years ago. Pretty shocking, actually. So this is an example of a few different things, something we call direct object references. Direct object references meaning 101 correlates directly to an account number, 102 directly to another account number. The thing to be aware of with direct object references is, what if someone guesses the next one? Now, even if these were randomized 3-digit numbers, and there were only 5, what are the odds that I would guess one of the other ones? Well, even if I don't guess it, I'll just script and iterate through until I get them all. So you have to think about in your access control model, when someone else figures out that number, do you have access control to effectively limit that access? There's another lab that we'll just talk through real quick, and the idea of this example is to exercise a piece of functionality you weren't intended to have. And so when you log into the account in this Goat Hills Financial, you'll log in with an account called Tom. And Tom will have a few options. He'll have like an edit profile and a view profile. But Tom's decided that he no longer wants his account, and despite his attempts, Goat Hills Financial will not delete his account. And so he looks into the way that the post requests are sent, and he sees that when he wants to view his profile, he sends a post message, and that post message includes an employee ID number and an action. So if you were Tom and you wanted to delete your profile, there's no button to delete profile, but you can probably make an educated guess on how you would do that. So you would go and say, well, there's edit profile, there's view profile. I'm going to guess that there's also delete profile. So Tom just intercepts with a proxy like Zap. He changes view profile to delete profile and sees what happens. Now, if you were to run this example in the lab, you'd see that that would work. He was able to delete his profile. And the reason is because the developer made the decision that, well, the delete profile is not accessible to Tom, therefore, I will not show Tom the button for delete profile. And then he moved on to the next feature. But just by not showing him something didn't actually enforce access control, because remember, we can always craft any message we want, and Tom would make this reasonable guess that an action of delete profile was there. So you need to have access control built into your business layer as well as your view layer, so that when the business layer says, Tom is trying to delete his account, is this action authorized for Tom? Your access control model says no. Now, if you were the attacker, what else would you do when you looked at this page? You would, yeah, exactly. You change the ID next. You say, hey, there's an ID. I wonder, can I view 104, 103? And if it was me, the first one I go to is ID equals 1, because that's probably the admin. But yep, those are the kinds of things you would do as an attacker. And if your access control model holds, that's fine. People can keep iterating on this all day. But if you've never thought of this as a developer, you could have some really critical flaws. So the key messages around access control is the access control needs to be performed server-side. Everything that we do client-side via JavaScript is nice. It makes the page pretty. It makes things that shouldn't be displayed grayed out. But an attacker can always get around that, so it's never an actual defense. The idea of security by obscurity, you should just realize that that's not going to hold. If you have a series of numbers of 1 through 10,000, and 100 of them are valid, that's obscure. Yeah, people may not know which ones are the right ones, but they'll quickly automatically iterate with scripts. Any sort of identifier, just think through what you're doing with that identifier if somebody changes it. And as we talked about with the Telnet example, realize that the attacker can send anything they want. And so they can make intelligent intelligent guesses. They could very well have your source code because your source code linked, so be prepared for that. Again, cheat sheet from OWASP on access control. So the web code examples we went through, we demonstrated 2 of them. There we go. What you'll see in WebGoat is that there are a ton of other examples here on the left of the page. Each of these have lots of drop-downs with lots more activities. Within them, they also have hints. You can see parameters, cookies, the Java, and they even tell you the solution. So if you're interested in learning more about how to actually exploit these flaws and do them in this application, this is a really excellent learning tool. Working through all of these different exercises will put you far ahead of most people in terms of security and most likely illuminate a few ideas that you weren't aware of. So I do encourage people to check that out more. Now, the other thing I wanted to talk about was around who's monitoring your traffic. I think this topic is particularly relevant given the recent news of the last year. So a few years ago, I did some work on a cheat sheet for transport layer security. So SSL, also known as TLS. And I talked about the ways people often do this wrong in applications. So if you think about SSL and you think HTTPS, as long as there's an S, everything is great. That's really just the surface. And there's a lot of different ways that things can go really horribly wrong. And again, that's separate from the crypto. The crypto, the CA, all of that stuff is a whole other bag of potential problems. So I'm going to do a couple slides to focus on how applications can often do this wrong. So imagine this scenario. You go to your bank and you log in over SSL, HTTPS site.com/login. So everyone's been trained, as long as you see HTTPS when you submit your password, everything is great and grand. But what you don't notice is after you log in, you get redirected to HTTP. And this was a really common practice a few years ago. The rest of the site you would browse over HTTP. And if you were to ask that site what they were doing, they'd say, well, don't worry, the password is encrypted. Everybody is safe. And that is true, the password is encrypted. But again, as we talked about before, I don't care about the password, I'll just steal the session ID. And so right here, you're logged in and your session ID goes across every single time. So if I'm a man in the middle, if I'm at a hotspot with you at the Starbucks, I will just steal that information and log in as you without problem. Now this finally got fixed in most websites, not because they finally listened to security practitioners harping about this for nearly 10 years, but for a different reason. Anybody know what that might be? A tool that got released? Firesheep, that's right. So Firesheep was a plugin for Firefox. Firefox had nothing to do with this. It was just the fact that they used that browser as a plugin. And Firesheep demonstrated this attack in real time. It said, here are the people sitting near you. Here are the Facebook accounts they're logged into. Which one would you like to take over? Just click on it. Now, fundamentally, nothing has changed. The technical vulnerability that we've been harping on for years, same exact one. But all of a sudden, you, your sister, your brother, your grandma, and uncle can all go take over each other's accounts in Starbucks. And at that point, there is no, sites couldn't ignore this anymore. Like, all right, we have to fix this. And they made the simple but correct solution of making both of these SSL. Everything from when you log into a page to when you log out, and in between has to be SSL. Now, even if you do that, there's still this other scenario. Say you want to log into your bank, and you don't remember your bank's URL. You don't want to type in the wrong one, because there could be somebody squatting on a typo domain to try and fool you. So you Google for it, and you know that Google will, or at least typically, returns it as the top result. So you Google for your bank, you click on the link, and then you end up at your bank's website, https mybank.com. So this is where you end up. You log in, everything's over SSL, the whole bank's over SSL, it's all great. The problem is that very first click at Google sent an HTTP request, more than likely, off to your bank. Your bank said, whoa, don't come to me over HTTP, that's not safe. Please turn around and go to HTTPS, which you did. But again, here we have a problem. If you're under an attack of man in the middle, I will intercept that very first response, and I will send you off to https mybank.com with an O instead of an A. or something similar. And all of a sudden, all you notice is you're at an HTTPS site. It looks like my bank because it's very similar. You enter your username and password, and bam, I have your information. So even though you wanted to do everything right, there's still this point in the middle where you weren't able to because your information went off in the clear. We'll talk about how you can fix that. So when you're building your web application, a few things. One, you have to use HTTPS throughout the entire application. If you don't do that, then it's just game over. That's 101. Now, the thing that you can do to protect against that second scenario, and also the scenario where someone bookmarks the HTTP link, is to enable something called HSTS. That is HTTP Strict Transport Security. This is an opt-in security control that will tell the browser to upgrade security with your site. When this has been enabled, the browser will ensure that every piece of communication sent by the browser to your site goes over HTTPS, no matter what. Even if the user types in HTTP manually, the browser will still upgrade it before it leaves the browser. And so this means there's no insecure HTTP request sent. And furthermore, if a person is under attack by a man in the middle, and they're trying to intercept the SSL, normally the browser will pop up an error message, which you've all seen, warning the site is not trusted, something along those lines. Would you like to continue? Which everybody pushes, yep, let's just keep moving. When HSTS is in place, it will disable that override, so you cannot move forward. Because what the browser is saying at this point is, this site has told me we were doing real HSTS, or real HTTPS. If there's a problem, that's an attack, and we're not moving forward. So graphically, this is kind of what it looks like. Even if I type in HTTP, the HSTS within the browser will upgrade that connection. That way, everything over the wire is SSL. So this is an opt-in security control that you'll turn on in your web server. It's actually sent back to the user as a header. And then the browser will remember that. Other topic I want to jump into, secure data storage and protection. Password storage. Despite how we keep trying to do this, people continually store passwords incorrectly. A major breach from a major software manufacturer with 50-some million passwords that were exposed, they were encrypting their passwords. And so anyone that's looked into this, encrypting doesn't make a lot of sense because encrypting implies you want to decrypt your passwords, which is just totally wrong. What you want to do with passwords is you want to hash your passwords. Hashing, the difference between hashing and encryption is encryption you can encrypt and you can decrypt. Hashing is a one-way operation. You take a plain text value, you hash it into the hashed value, and you can never go back, which means if the hashed values are stolen, you can never recover the clear text password from the original password. Now, when you do hashing, there's a lot of ways to do that. You could do something with, you could do MD5 hashing, you could do SHA-1. Those are all old ways that are now broken. You don't want to use any of those. The correct way is to use something like bcrypt or PBK-DF2. What these algorithms do is they include a work factor. Because the other threat to hashed passwords is that I will pre-compute all the possible values. So let's say I take the dictionary and I hash every single value and I store it in a database. And I say, all right, well, I have your hashes. I can't go backwards, but what I could do is take it and look it up in my dictionary. And that's a rainbow table attack. And so if you make dictionaries large enough, you do every single word with every single number, you suddenly have gigabytes of data that you can do database lookups against and quickly determine the real value of the password. These bcrypt and PBK use work factors that make it many iterations of hashing, so it's no longer feasible to generate a rainbow table because every single operation now takes more milliseconds than before, to the point where in mass it's going to take hundreds of thousands of years versus a month. So you want to consider using these, and the other nice thing about them is as computing power increases, you can actually change the work factor so you can keep up with additional computing power. The other thing to think about with passwords and authentication is to be very clear about what is your system protecting you against. All too often I hear, well, it doesn't matter if we hash the passwords because we have account lockout. And the problem here is you're mixing two different security concepts. For password hashing, we are protecting against a scenario where a malicious admin takes the passwords, or there's a vulnerability and they do a SQL injection and they steal the passwords, and they have this list of hashes offline on their own machine where the attacker is pummeling it with different operations to try and figure out what the password is. That scenario is not impacted at all by your online attack, where you have things like account lockout or maybe IP blocking, but again, you don't want to block universities, so be very careful with that. So when you think about password hashing and online attacks versus offline attacks, you just want to keep that very, very clear. And one other thing I've talked about recently is around how could you store very sensitive data? What would a design look like for something like that? And so two things. One, consider internal SSL. Also consider there's a... Oh, interesting. Nope. Yep. I had a talk a few years ago, and I don't remember the context of what I was saying, but the word NSA was going to come into it, and right when I said the word NSA, there's massive feedback, and it was actually kind of scary. The idea here was consider internal SSL, so you protect the data as being transmitted on your internal network. And there's also software and tools that will let you monitor database queries and response size. If somebody starts doing something bad with your database and starts ciphering out lots of data, there's not a lot of good ways to know that. And so there's some tools that will monitor that so you can have a better idea of what data is leaving your network. The other thing is some applications need to store incredibly sensitive data. There's not a lot of situations where you would store someone's password and need to recover it. But if you're in a scenario like an aggregator service, or you're logging into some other service on behalf of a user, or you're doing some sort of encryption with a key like a cloud storage type thing, you may have a key that you need to be able to access. And if you just hash it, you can't access it because it's a one-way operation. So this is a simple example of an idea you can use where you take sensitive user data and you're going to encrypt that. When you encrypt something, you need a key to do the encryption. So you have a customer encryption key. Now, the problem with doing this is when someone's using customer encryption keys, any company or customers using that service says, well, who can access your encryption keys? What about insider attacks? What if those encryption keys get stolen along with the data? The way you can mitigate that is by using one additional key, which is called a key encrypting key. Now, you may be thinking already, well, why don't you have, well, who could steal that one? You could go down the line and have hundreds of keys and get silly. But what you do here is you actually use a hardware security module. And if you haven't heard of these are physical crypto devices that are designed to be tamper-proof and be able to perform cryptographic operations. And you set that up as a service, and then you can actually you encrypt and decrypt your encryption key with your master key encrypting key to then use it on the data. And in this situation, you have heavy controls over the operation of the service. Who can access that? It's only a small number of people with additional security layers. So you can dive very deep in this, but if you're thinking about complex architectures to do encryption, think of HSMs, think of a key encrypting key, and that kind of approach. The last thing I wanted to talk about were some new growing threats that are coming after applications, new things on the horizon to be aware of. And then we will have a few minutes for questions. So you've heard about denial of service, and you've probably heard about either a denial of service or a distributed denial of service. So just to level set on what those two are, denial of service is one person trying to be bad and trying to send a lot of traffic to your website. Distributed is let's get everybody and our friends and an entire botnet and have them all send traffic against a website. In most situations, the goal is to do a network-based denial of service. This is the ones you're hearing about the most right now. And what they're doing here is they're trying to get enough machines to make enough requests so they can exhaust the network bandwidth. Now, there's 500 plus million compromised machines around the world that can be served in botnets. You can rent those for about $2 an hour for, I think, 10,000. It's pretty trivial to start doing this type of operation. Now, there's been a fair amount of research into how to defend against these types of attacks. You can do things like CDNs. There's different cloud-based products that will help you against volumetric network exhaustion attacks. But the next thing that's coming is application layer DDoS. And this is slightly different. The goal, of course, is still the same. Let's bring down the server so other people can't use it. But instead of trying to overwhelm the bandwidth, what I'm going to do is trying to overwhelm the CPUs and the memory of your servers, either your web servers or your backend database servers. And the way I'm going to do that is I'm going to look for something that's intensive, memory intensive or processing intensive, like generate report. Most often, a generate report type functionality will take 5, 10, 20 seconds of spinning to generate that report. And what I'll do is I'll instruct my botnet to then all use that exact request. Now, if we have hundreds of requests all to generate a report at the exact same time, that CPU spikes and makes it unavailable for other operations for other users. And so this type of attack is the next thing coming down the pipe for attackers to take sites offline. Just comparatively, the traditional network DOS is trying to overwhelm the target with volume. The application DDoS is a smarter, more precise attack, going after computationally intense operations, targeting the CPU or memory instead of the bandwidth. And in many cases, an application DDoS doesn't require as many machines. Depending on how vulnerable the site is, you could find one where it just takes you and a few other machines, or maybe just a few processes on your machine to really bring that server to its knees. Next up is account takeover. As you continue to see more data breaches, the one thing that happens is all of those username and passwords are on the web. And as we talked about with password storage, most websites aren't storing their passwords securely. So as a result, every time there's a breach, there's a treasure trove of usernames and passwords that comes online. From the large software breach of 50 million accounts, you can see that 6 million of those usernames and passwords are already known. You can use them right now. The top 100 passwords were figured out by frequency analysis, by password hints. The very top one is 1, 2, 3, 4, 5, 6. So, anyways, you can take that entire list of 6 million usernames and passwords that were valid at that site and say, how many of those are valid on your website? What I would do as an attacker is I'll steal these passwords from the compromised server or for wherever they're posted on the web. I'll try them on your website. And I could try them all from my machine, or I could use a botnet and have every machine in the botnet try them once each. At that point, you can't tell if it's a legitimate attacker or a regular user just trying a password that doesn't work. And if I was to say from that treasure trove of usernames and passwords, if I took 6 million of them, what are the odds that a few of those work on your site? I'm guessing that username password reuse is pretty common, especially amongst people that choose 1, 2, 3, 4, 5, 6. So unfortunately, every time there's a breach, you're in the situation where how many of these breached accounts now result in breached accounts on our site. Takeaways. Definitely understand the top threats. We stepped through a few of them. I highly recommend to read the OWASP Top 10. It's not a long document. Those are definitely the top issues that are going to be potential risk to your application. Again, don't consider any top X list to be a security program. There's way more than that, but you should be familiar with those. Sensitive data, you need multiple controls. Think about transmission of data and also storage. And then in terms of, don't get caught up in what the old stuff is. Be prepared for the old stuff, but also start thinking about what's new, what's coming down the pipe. This lab was called the OWASP Broken Web Application Security Lab. Definitely use that and learn more. And there's a ton of resources also on OWASP. And as always, there's my contact info. And we do have a few minutes for questions. Yeah.
I know as far as DDoS attacks, at one of my old jobs, we had something called a DNS amplification attack, which was a huge deal, which was, for those that don't know, effectively it multiplies attacking traffic and hits back about 5, 10, 20 times harder. But have you seen stuff like that in the wild very much, and is that being mitigated at all?
I have seen a few attacks using the DNS amplification, so I'm definitely familiar with the term. I have not dove in to see what the best practices are for mitigating against that one yet, though. So unfortunately, I don't have an answer for you on that. It's probably out there. I just haven't dove into it. Do you have there we go, a question over there?
With regards to password security, is there any reason that I would want to obfuscate the SALT for a particular user, or is it okay to have a SALT in clear text?
Yeah, the salt, the key thing about the salt is for it to be different per user. Because the goal of a salt, and I didn't mention it, the goal of a salt is so that if two users choose the exact same password, they don't have the same hash because you have an element of randomness put into each one that's different. The purpose is to also prevent against rainbow tables. If I do a rainbow table and have the hash for dog and cat, and you choose the password dog and cat, once you add the salt, your hash is different, so it's defeated my rainbow table. So you do not need to, the secrecy of the salt is not important. It's only the fact that you have one that's different per user. And we have time for one more question, way in the back.
So one of the things I've seen with certain websites is that they'll give you HTML and JavaScript, things like that, through SSL, but they'll give you CSS and other presentational things through HTTP. Does that create a security risk there?
It definitely does. A more egregious example of that is I've seen a site that had HTTP as the main page and then an iframe for the login of a SSL. And they said, oh, it's over SSL, it's secure. Again, true, the username and password is secure over SSL, but now we're jumping into the expectations of the user. As an attacker, I will just modify the outer frame and replace the iframe with something else. The user has no idea. And so the same thing with CSS or other elements. If I start changing those, I don't need to technically defeat encryption. I just need to fool the user enough to give me their password somewhere else. So when you use SSL, you need to avoid mixed content, which is exactly that scenario where you have SSL and HTTP. Because at that point, it's free-for-all for the attacker just to fool a user. Well, again, thank you very much. I hope you can check out that material. And as always, I'm open for questions afterwards at those places or in the hallway. Thanks.